One spark that changed everything. Life was born. Was Earth truly the first planet to develop life? The solar system formed approximately 4.6 billion years ago from a collapsing cloud of gas and dust, known as a molecular nebula. This collapse was not orderly. It was driven by gravity, turbulence, and angular momentum. As the cloud condensed, most of its mass fell toward the center, forming the young sun. The remaining material flattened into a rotating disk, the protoplanetary disk, from which planets would eventually emerge. In this early stage, the solar system was a violent environment. Collisions were frequent. Orbits were unstable. Planetary bodies were still growing, merging, and being destroyed. Nothing resembled the calm architecture we observe today. The young sun itself was fundamentally different from the modern sun. During its early evolution, it emitted higher levels of radiation and energetic particles. Its luminosity changed over time, slowly increasing as nuclear fusion stabilized in its core. These changes mattered because the amount of energy a planet receives from its star is the primary factor that determines surface temperature, and therefore whether liquid water can exist. This brings us to the concept known as the habitable zone. The habitable zone is often described as the region around a star where conditions allow liquid water to exist on a planet's surface. But this definition is frequently oversimplified. The habitable zone is not a fixed boundary. It is not a guarantee of life. And it is not a permanent property of a planetary system. It is a dynamic range that depends on stellar luminosity, atmospheric composition, and time. Most importantly, it moves. As a star evolves, its energy output changes. When the sun was younger and dimmer, the habitable zone was closer in. As the sun aged and brightened, that zone gradually shifted outward. This means that habitability was not a static condition assigned to a single planet. It was a phase that different planets could pass through at different times. Planets did not migrate into the habitable zone. Rather, the habitable zone migrated across the planets. During the early history of the solar system, this movement had profound consequences. Earth, at that time, was not yet the stable, water-rich world we know today. Its surface was repeatedly reshaped by impacts. Its atmosphere was evolving. Its oceans, if present at all, were not yet persistent. Venus, meanwhile, occupied a region closer to the sun, a position that today places it far outside the habitable zone. But in the distant past, that was not necessarily the case. Climate models suggest that early Venus may have received an amount of solar energy comparable to what early Earth received later. Under certain conditions, this energy balance could have allowed moderate surface temperatures. If Venus possessed a sufficiently thick atmosphere, it could have supported liquid water. Not necessarily deep oceans, but lakes, shallow seas, or episodic water stability. These conditions, if they existed, may have persisted for tens or even hundreds of millions of years. In planetary terms, that is a significant window of time. Crucially, Venus and Earth formed from similar materials. They are similar in size, mass, and bulk composition. They began as neighboring worlds, shaped by the same early solar system processes. Their divergence was not inevitable from the start. It was the result of subtle differences in distance, atmospheric evolution, and feedback mechanisms that amplified over time. If the habitable zone passed over Venus before it settled around Earth, then Venus may have experienced habitable conditions earlier. This does not imply that life existed there, but it establishes something equally important. It shows that the possibility cannot be ruled out based solely on Venus's present state, because planets remember their past, even when their surfaces no longer show it. If habitability reached Venus first, then the question of where life began becomes less certain. And if habitability is a moving window rather than a fixed location, then Earth may not represent the beginning of the story, but a later chapter in a much longer process. When we look at Venus today, it is difficult to imagine it as anything other than a failed world. Its surface is hot enough to melt lead. Its atmosphere is dense, toxic, and crushing. But planets are not defined by what they are now. They are defined by what they once were. And Venus may have had a very different past. Based on current climate models, early Venus could have experienced a long period of relative stability, not paradise, not a perfect Earth-like world, but a planet with temperatures low enough for liquid water to exist under the right conditions. If Venus possessed a thick atmosphere early on, it could have regulated surface temperatures more effectively than we once assumed. Cloud layers may have reflected part of the incoming solar radiation. Water vapor could have existed without immediately triggering a runaway greenhouse effect. This balance would not have been permanent, but it may have lasted long enough to matter. In biology, time is everything. Life does not require ideal conditions. It requires persistence, chemical reactions repeating again and again over vast stretches of time. If Venus maintained liquid water for tens or even hundreds of millions of years, then it had something crucial: a stable window. A window where complex chemistry could begin to organize itself. Venus was also closer to the Sun than Earth. That meant more energy was available at its surface. Energy is not just a threat to life, it is also a driver of complexity. More energy means faster reactions, more variation, more opportunities for molecular structures to form, break apart, and reform in new ways. In its early history, Venus may have been a chemically active world, not calm, but productive. If life were to emerge anywhere first in the inner solar system, Venus cannot be ignored. This does not mean life did emerge there. There is no direct evidence. But absence of evidence is not evidence of absence, especially when a planet's surface has been almost completely erased by geological processes. Venus does not preserve its ancient history the way Earth does. Its past is hidden beneath layers of heat, pressure, and time. And this leads to a more uncomfortable thought. If Venus once hosted the conditions for life and later lost them completely, then habitability is fragile. It can exist and it can disappear. Planetary environments are not promises. They are temporary states. If Venus was the first harbor, then Earth may not represent the beginning of life's story, but its continuation. A second opportunity, a world that remained stable just long enough for life to survive and evolve. If life can emerge and then be erased, then the universe may not be hostile to life, just indifferent to its survival. And if Venus failed once, the question is no longer whether life can begin. The question is whether it can last. What do you think? Was Venus the first harbor of life, or a missed opportunity? Share your thoughts in the comments.